everybody. Today we're going to be looking at rate influencing factors. So a couple weeks ago you guys did a little project where you looked at how different factors affect the rate at which chemical reactions occur. And this is the time in class where we usually do a couple labs to back up what you have learned. But we can't do this, so I thought I'd bring a couple of those lab experiences home to you. So you guys, on this video there'll be some demonstrations of some chemical reactions, and there are some questions that go along with those demonstrations. So you guys can watch the whole video and then go and answer those questions at the end. So before we finish up and take our test for this unit, I just wanted to go over those rate influencing factors one more time. Those factors include the learning target is, I'm just going to read it to you. It says, this means I know how concentration, surface area, temperature, and the presence of a catalyst affects the rate of chemical reaction. So in today's video, we are going to look at concentration, temperature, and catalysts, and how those things, how switching up those things can change how fast or slow a reaction occurs. All right, for our first demo today, we're going to look at how the temperature of a substance affects the rate of reaction. So I have these cool things, they're called Whack-A-Packs, self-inflating balloons. So what you do with them is you hit them, and there's like a little like pocket inside, and it'll break open, and it's a combination of citric acid and sodium bicarbonate. So basically it's like vinegar and baking soda when you mix them together. So they're gonna make a bunch of carbon dioxide and blow up. So I have one here that's room temperature, and then I have one in the fridge that we're gonna compare. So I'm gonna put the warm one here, and the cold one's gonna go here. And then we're gonna see which reaction happens faster. Okay, so this is the room temperature one. This is the cold one. We're gonna break them at the same time, set them down, and see which one pops first. Okay, I'm ready? Ready, set, go. All right, so we got the cold one, rate of reaction here. The warmer things are, the faster the reaction happens. The colder they are, the longer the reaction will take. So I want you on question 1 to tell me why. Why do warmer things happen faster than colder things? For the second demonstration, we're going to look at 2 different factors that affect rate of reaction. One is a catalyst, and the other one is the concentration of a substance. So for this one, we are going to be doing the classic elephant toothpaste demonstration, and we're going to do that with using hydrogen peroxide, 2 different kinds of hydrogen peroxide, and then our catalyst for this experiment is potassium iodide. So what the reaction is that's happening is the breakdown of hydrogen peroxide into water and oxygen gas. So hydrogen peroxide, you guys know by now that it's H2O2. And when you let hydrogen peroxide sit, it just naturally turns into water, and then the oxygen gas escapes. But that reaction takes a super long time. Like, you've probably had hydrogen peroxide in your cupboard at home for a while, and if you put it on your cut, it would still sting. So it takes a while, but we can make this reaction happen super fast by catalyzing it with potassium iodine. And potassium iodine is a catalyst, and a catalyst is just something that doesn't affect the outcome of a reaction, but just makes it happen a lot faster. So this potassium iodine is going to make the hydrogen peroxide breakdown really, really fast. The other thing we're going to look at is concentration. So I have 2 different kinds of hydrogen peroxide here. The first one is the kind that you would buy from like Walmart or the drugstore, and if you look at the label, it says that it's 3% hydrogen peroxide. So only 3% of what's in here is actually that hydrogen peroxide. The rest is just water. So this stuff is like safe for you to touch and use as first aid, and it's the stuff that you're familiar with. This one though, this is like the souped up version of hydrogen peroxide, and this one is 30%. So this concentration is a lot higher. There's a lot more actual H2O2 molecules in this bottle than in this one. So we have a high concentration and a low concentration. This stuff is not safe to touch. I'm gonna be really careful when I'm using it. It's not safe to touch. I don't wanna get it in my eyes. But we're gonna see what kind of reaction happens if I do the catalyst in the low concentration versus the catalyst in the high concentration. The other thing that I need for this experiment is I need some soap, because the only way we're gonna see the actual oxygen that's being released is if we have something to catch the oxygen bubbles. So when this reaction happens, all the oxygen is going to get stuck in this soapy bubble solution. So we're going to see a bunch of bubbles, and that's what actually makes the reaction really cool. So we're going to go outside and do this one in a minute. Okay, the first one we're going to do 3% hydrogen peroxide. This is the low concentration. We got a color change. We know a chemical reaction is occurring. We got bubbles. We'll give it a minute. I'm going to take you in closer so you can see what's happening. We got some bubbles down there going, a little bit of foam. Not a lot of action, but we are making oxygen gas. Give it a little stir. Okay, now we got 30% hydrogen peroxide in our flask. I'm going to add our catalyst. This one happens a little bit faster. You want to notice all that stuff coming off there? That's steam. So one of your questions is if this experiment is exothermic or endothermic. If it's making a bunch of steam, what do you think we got? Also, you're going to tell me, do higher concentrations or lower concentrations happen faster, and why? Isn't that beautiful? So now that you've seen how temperature affects rate of reaction, concentration, and catalyst, I want you to jump on. There's a couple questions for you to answer about what you saw in today's video, so go ahead and answer those. And that will cover Learning Target 3 for this unit, how I can identify rate influencing factors. Have a great day, everybody.